Hey folks, welcome to what I hope is going to be a really cool tutorial on some cool stuff I was doing with geometry script in Unreal Engine, making this really cool dynamic destructible environment kind of stuff. Now, before we get into it, I do have to point out that this is not game-ready destructible environments. It's particularly system intensive. It's not really, it was never really set out to be a destructible environment. It was set out just as a fun way of me exploring geometry script and learning what it can do. Also, the geometry scripting stuff is still in beta, so if you're looking at like an actual in-progress project, maybe not a good idea to drop that in just yet. But it is good to learn about it, get ahead of it, so that once it drops out of beta and into full release, you'll be on top and ready to work with it. There are some prerequisites to this video. I'm assuming that you already know your way around blueprints to some degree, that you know actors, you know variables, you know inheritance, and you know a little bit of like actor to actor communication, that kind of thing. That said, there's no C++, there's no complicated vector maths, nothing too complex going on in here. Finally, it's worth mentioning that I am a teacher, and this video is going to look just as much at system design and the way you think about things as a system designer as it is about the actual implementation. I really like to walk through the thought processes and the approaches that you're supposed to take to help people kind of learn how to work in this field, how to work in this role, rather than just showing you how to do some cool tips and tricks. It does mean the video is going to move a little bit slower than some of people's videos do. That's just my approach. I do think this will be better for you if you're looking to become a system designer. So for me, where this started was scrolling through the geometry script API. Every system design should have some research at the start, so for this kind of experimental approach, this kind of learning approach, this was the best place to start. Figure out the sort of dry, dull functionality of what the tools can do. What jumped out at me from this was booleaning. So if you don't already know, when you're doing sort of 3D mesh modeling, booleaning is where you take one mesh and then you use that to sort of cut a hole in the other mesh to make a space in the other mesh. And this is normally used to, you know, like punch holes in things or chop corners off things. This is where system design gets fun. Because as a system designer, what you should be able to do is see the dry, dull, functional side of things, and also the sort of like really dynamic, exciting, real world side of things, or in this case, digital world side of things. And at all points, you're kind of bouncing between these two worlds. So as a system designer, when I read something and I see the capacity to remove a piece of something or to delete a piece of something, I also think destruction, you know, actually demolishing things, breaking things. They're not exactly the same thing, but I do see the capacity for one to represent the other, and that is basically how system design comes about. And then you get to this other point that was in the API, which is Perlin noise. And if you don't already know, Perlin noise is basically just a way of adding randomness to something. It's something that, from a systems perspective, I get excited when I see the capacity to add Perlin noise to something because it makes it dynamic, it makes it weird, it makes it interesting, it messes things up a little bit. And in this case, as soon as you start talking about taking a chunk out of something, talk about that chunk having a sort of random shape to it, a sort of jagged edge shape, that's an impact crater. Okay, that's what that creates. It's an impact crater. And that's really cool. So we've got an idea. We're seeing things in the API that say that it is technically kind of feasible. Okay, so we should be able to make this. So let's hop over to Unreal and actually try this out. Okay, so here we are in Unreal. I've got 5.3 open. You could be using 5.4. As far as I know, it won't really make much difference, I don't think. This, as I said before, is not like proper system design on a project. It's experimenting with stuff. I would always advocate experimenting with stuff in a nice, clean, sterile environment. So don't open an existing project with a bunch of stuff already in it. Open a nice separate project. I'm going to go with the first person template because it's got projectiles in there and we'll probably want to use those later for stuff. I'm also going to leave the starter content checked because that gives us some props and stuff that we can play with. Give it a nice name, so let's call it destruction test. You can see destruction's already taken there because that's the actual project that I've experimented with all the stuff in before. Create that, and before we do anything else, we are using a plugin for this. It is a plugin that comes as standard with the Unreal Engine, but it's currently in beta, so it is not enabled at the start. So in order to enable this, we're going to have to go Edit, Plugins, and you're looking for Geometry Script here. It is in beta, so it's warning us to be cautious. Don't put this in a shippable product because it may change, it may break, it may have platform-based support issues. But for now, yeah, let's enable and let's restart because we're just playing around with this for just now. So here we are in Unreal for the first time with our new project. So the first thing we're going to want to do is we've got to think this through in steps. Okay, so the other thing about the way that a system designer sees things, yes, it's the ability to see something really, really cool that we want to make happen and the functionality and the tools that will make that happen. It's also the ability to break this down into smaller versions of the thing and go step by step and not try and rush it. If you try and jump to this bit right away, you're just going to get yourself frustrated and annoyed. So a first step along the way, if we can't boolean one mesh from another, we can't make an impact crater. And if we can't generate dynamic meshes, we can't boolean the dynamic meshes. So let's start with generating the dynamic mesh. I'm going to open up here and let's start a new folder here. Let's try and stick to good practices while we're doing this. Let's make a folder called Destruction. We'll right click, go Blueprint Class, New Actor, and I'm going to call this pp underscore Boolean Test Actor. Okay, let's open our actor. Now, I have been reading the API a little bit, so I know that a dynamic mesh, like a static mesh or a skeletal mesh, it requires a dynamic mesh component to be added. I could add a dynamic mesh component up here. It's in here somewhere. But I know that I'm going to want to work on this in a dynamic fashion with things. So I think the thing to do is actually, let's make the dynamic mesh dynamically at runtime. So let's go with begin play. We only need it to run once. And we're going to add a dynamic mesh component, like that. And we're going to promote this to a variable so that we can track it later on. Let's give this a name, so let's say box mesh, because we're going to make a box with it. Now, as I said, this component is the component that contains our dynamic mesh. It is not the dynamic mesh itself. So we want to get the dynamic mesh from this. Let's actually, no, get dynamic mesh component, get dynamic mesh, that's the thing we want, yep. And then let's promote this to a variable so that we can access both of these later on. And let's call this, you know what, I made a mistake. It's going to get confusing if we start calling a mesh component a mesh. So call this box mesh component. And then let's call this box mesh. That way we know whether it's the component or the mesh. Okay, so naming matters. Keep you straight, it'll prevent future headaches. So now that we've got our component, we've got our mesh, what we want to do is drag off of this and we want to add a box. So when we say generate something, like we've generated a dynamic mesh and that dynamic mesh is empty, and then we're adding a box to this. So it's called append, and we're just going to say append box. 100 by 100 by 100. We're just going to leave the transform as it is. Okay. And we're going to see what we learn from this. We're going to see how this works. So in order to test this, make sure it's saved and compiled. There's our player start. Let's take this, let's drag this out to here. Now it's obviously not going to appear with a box because that is happening on begin play. But if I hit play now, there's your cube, there's your box. Now, this tells us a couple of things. So first up, it tells us that we can, yes, generate dynamic meshes. We've done that. It also tells us, because this cube appears here, and our player start is here, and the coordinates of this are 132, 1020, 150, that this transform, so if I split this up so you can see it, the position 0, 0, 0 is relative to the position of the dynamic mesh component, which is sitting at 0, 0, 0 in the actor. Okay, so we have now also learned that dynamic mesh stuff works mostly, or when it just has a transform here, it is local transform, it is not in world space. Okay, and that's important to know. These things are important to pick up on as you're going. Next, we want to boolean this with another mesh. So we need another mesh to do the booleaning with. Let me just make this a little more visible. So to keep things nice and tidy and readable, I'm going to highlight all of these and I'm going to add a comment. I'm going to say generate a box mesh, because that's what that does. And just to keep things readable, mostly just for you guys, I'm going to put sequence in here. So first, sequence 0, generate a box mesh. Now, in order to do the booleaning, we're going to need another mesh. If we're going to get another mesh, we're going to need another dynamic mesh component. Let's do that. Now, for reasons that will become apparent later, I'm going to call this a tool mesh. I know that sounds like a weird thing to call it, but since it's a tool we're going to use for the booleaning of the box mesh. So let's call this tool, and obviously we have to call this tool mesh component so we don't get mixed up. Let's get the dynamic mesh, and again promote to variable, and we'll call this tool mesh. Okay, and now let's append a sphere. We have two options here. We've got a sphere box, we've got sphere latitude, longitude. I'm just going to go with sphere box. So we just give it a radius, again, transform of 0. Now, let's look at our positions here. So our icon down here, we've got X going into the screen. So X going up this way. We want the sphere to be a little bit closer to the player. So let's do like, it's a radius of 50. Let's do like minus 20. Let's minus 20 on X. What that should hopefully give us, yeah, so it's pulled forward a little bit. It's also sitting at the bottom. So think about what that's telling us about the origin points and the positioning. Okay, it's everything is, that box is generating up the way from the origin point, and the sphere is generating out the way from the origin point. Okay, so the origin point of the box is actually technically at the bottom, which is interesting to know. Let's see if we can bump that up. So again, you know, and this is how bad I am with 3D space. As much as I love doing this stuff, I always sort of double check Z is up here, so positive value for Z. Let's say 25 should put it should put it in the middle of that cube, and it doesn't. Because the cube's 100. This is radius of 50. The cube is a radius of, yeah. So 50. That's radius versus diameter. There we go. Okay. So we've got our mesh. We've got our tool mesh. Let's keep things neat and tidy. Let's highlight this and say sphere for tool mesh. Now comes the fun part. We're going to boolean one of these out the other. So let's do this. Drag down here. Now, does it just let us drop the node? Do we need the context? Apply mesh boolean under geometry script. So here we go. Apply mesh boolean. Now we have got a target mesh, target transform, tool mesh, tool transform. So the target mesh, we want the box mesh, that's what we're applying the boolean to. And then the tool mesh, there we go. Now, operation, we have union, we have intersection, and we have subtract. So the union is kind of like it welds the two things together and it deletes everything inside of it. The subtract is it takes the tool mesh out of the box mesh. An intersection is it only returns the parts that overlap between the two things. And if you're looking at that and you're thinking, or if I'm saying that and you're thinking, hey, I see where this is going, awesome, yes, you've figured part of it out. For now, we just want to subtract. We just want to take the sphere out of the cube. So this should work, but let's look. And we don't see anything. Why don't we see anything? We don't see anything because the sphere is covering up the hole that we're making. So what we need to do is get rid of our tool mesh. And we can, the thing that would make most sense to do at this point is just destroy the tool mesh component. And then if you compile this and run it, there we go. It is gone. Now there was one more step that we came across in the API, and that was adding Perlin noise to something. So let's go back here and let's keep it up here with the generate sphere. This here is our target mesh. This here is also the same mesh, but I'm just going to do it off this here, and it will show you that that tracks, it like still is updating the same mesh. It's not creating a new reference or anything. We're going to say apply Perlin noise to mesh. Now, this is an interesting node because it's got selection here, so later on if you look into more detailed stuff with geometry script, you find that because geometry script is meant to allow you to kind of do modeling stuff like you would in a modeling program, there is options to sort of select certain triangles, faces, vertices, whatever. If you leave the selection blank, it will just assume you mean the whole of the mesh. It also has this options part here, and if you hover over it, it's geometry script Perlin noise options structure. So it's not giving us options on the node like it would normally, but if you go here and you say make geometry script Perlin noise options, we get this. So apply along normals, empty behavior, which is basically what to do if the selection is empty. And then you have base layer here, which is geometry script Perlin noise layer options structure. And we want to look at these options, so let's make that, and you get this. So you have your magnitude, you have your frequency, you have your random seed. So I'm not really sure if this bit is necessary, but this random seed here comes in at 0, and it might generate a random seed when it's 0. I don't really know, but just to make sure it's definitely random. We're going to do a random integer, and Unreal's really handy for things like there is a max value that an int can be, so I just whack that up really high and it puts in the largest max it can have. This also gives us access to our magnitude and frequency, which is just kind of like how wobbly do we really want our Perlin noise to be. So frequency is like how wobbly it is, magnitude is, well, frequency is like how often it wobbles, and magnitude is how big it wobbles. There's probably mathematicians really upset with me calling it that, but that's how I see it. So that gives us the option to play around with that. I'm just going to move this out of that comment box. Let's go back in here, and you can see it's kind of raggedy. It's kind of raggedy around the edges. Go back, and if we think about it, our radius is 50, our magnitude is 5. Like 25 would dip about halfway in. So let's take a look at that. Yeah, that's crunchy. That is crunchy. I like it. It's a little broken actually around the edges. Might be a bit much. Maybe a little too crunchy. Let's do 12.5. Big fan of doing things by halves. Let's do a 0.125 here. Oh. This is at the point where it's just like, this is just fun and we're just playing around with stuff. Okay. Yeah, it's a little crazy. It's now poking through the sides because the magnitude is going to go up and down. But yeah, I think that's pretty cool. I don't like the frequency. Let's try 0.5 frequency. Yeah, I think that's about the level of crunchiness I think we want this to have. Now, we have got booleaning one mesh out of another mesh, but we're doing that with a basic cube. We know in the future we're probably going to want to do that with pretty much any mesh that we can choose to use, so we'll do this more dynamically. And we also have this problem to deal with. There is no collision. So, we have got our first step underway. We've learned how some geometry script stuff works. It's a good time to take a break, and I will make another video where we take the next step towards making this a more dynamic system. So I hope you enjoyed the video. There's the whole like and subscribe thing that would really help me out. Otherwise, if you want to jump ahead and do some cool stuff with this and try it out, leave me a comment, drop me a message somewhere, and let me know what you can come up with. Otherwise, I will see everybody in the next video where I show you how to add the collision and maybe do this with like some actually dynamically with existing meshes. Okay.